So first, let me define what a complex number is. Complex number. So far in math, we've dealt with real numbers, where we just have just a real number. Now we're going to throw in the imaginary part with it. So the form of a complex number is a plus bi. So a and b are real numbers. A and b are real numbers. And a is the real part, what we call the real part, and the bi is called the imaginary part. So we have the real part, but also now the imaginary part. So we'll see lots of examples of these as we get into the operations. So first, for adding and subtracting complex numbers, basically the little point I'll make here is treat I like x. Like I said in the last video with imaginary numbers, it's for a lot of purposes we treat I just like it's x. So let's say we have the complex number 6 plus 2i. So there's an example of a complex number. 6 is the real part, 2i is the imaginary part. And then we add it to another complex number, negative 3 plus I. And a lot of times we use parentheses to emphasize this is one real number and this is, one complex number and this is another complex number. We're adding them together. So it's really just like combining like terms. We're going to add the real parts, 6 and negative 3, which is a positive 3. Add the imaginary parts, 2i plus I would be plus 3i. Just like combining like terms with back when we started algebra. Now the next one, let's do 5i minus 2 minus I. So that first complex number actually doesn't have a real part. If you wanted to put one in, this would be like a 0 plus 5i. The real part would be 0. So we can have just the real part or just the imaginary part. So in this problem, when it's a minus, it's a good idea to distribute that minus before you do anything. So minus 2 plus I, just like back when we did combining like terms. If there's a minus, distribute that first. Okay, so my real parts is just negative 2. My imaginary part, 5i plus I, is 6i. And we typically, to be kind of follow the right format, we put the real part and then the imaginary part. So that would be my answer. Okay, so that was adding and subtracting. Multiplying. Multiplying. So the first one, let's say we have 2i parenthesis 6 minus 3i. So just like I said, treat I like x. We're going to distribute. So this is going to be 12i minus 6i squared. Now, now I can go a little further because remember, what is I squared? I squared is negative 1. So now I have a minus 6 times negative 1. That's going to become a positive 6. And I'm going to put that first because I'm supposed to put my real part first and then my imaginary part. So 6 plus 12i. Okay, how about 3 minus 4i times 6 plus I. So multiplying two complex numbers. So if you could probably guess, we're going to have to FOIL. So first, 3 times 6, 18. Outer, 3i. Inner, minus 24i. And last, minus 4i squared. So a little bit more work I could do here, though, because, well, I can combine the plus 3 and the minus 24, minus 21i. And then this is negative 1. I squared is negative 1, so that's going to become a plus 4. So 22 is my real part, minus 21i. Okay, one more, and this is going to be a good intro to what we do next with dividing. Let's say I have 4 plus 2i times 4 minus 2i. So 4 plus 2i times 4 minus 2i. Again, FOIL. So first, 4 times 4 is 16. Outer minus 8i. Inner plus 8i. And last, minus 4i squared. So my minus 8i plus 8i cancels. So I'll have 16. I squared is negative 1. So that becomes a plus 4. 16 plus 4 is 20. So notice how the i's end up dropping out, because that will always happen when you have conjugates. Remember conjugates back when we did rationalizing denominators, just basically the same thing but plus and minus in between the terms. We're going to use that same thing for dividing. So dividing. So with dividing, we multiply the denominator, or multiply, not denominator, multiply by the complex conjugate of the denominator. Multiply by the complex conjugate of the denominator. So complex conjugate being if it's a plus bi, we would do a minus bi. So let's say I have 4 plus I over 2 minus 5i. Okay, so I'm going to multiply by the complex conjugate of the denominator. So I'm going to multiply by 2 plus 5i on the bottom, which means I have to multiply by 2 plus 5i on top. Okay, and what really the purpose of doing dividing complex numbers is we don't want to be left with an I on the bottom. You can think of it that way, because it's going to just combine these into one complex number, which you'll see as we go through this. Okay, so on top, FOIL. First, 8, outer, 20i, inner, 2i, and last, plus 5i squared. Which maybe I'll do some simplifying on top right away. So that's going to be, now that 5i squared, hopefully you're starting to kind of catch on that this is just changing the sign because you're multiplying by negative 1, so it's changing instead of a plus 5, minus 5. So 8 minus 5 is 3 plus 22i. Okay, now on the bottom, first is 4. Outer plus 10i, inner minus 10i, and last minus 25i squared. The inside two cancel, the outer and the inner cancel. Minus 25i squared is going to become a plus 25, 29. So now, I mean, we could leave it like that, but what the whole purpose of doing this is to show that this is one complex number. We divided it to get one complex number, 3 29ths plus 22 29ths I. So I have my real part first, then my imaginary part, like I said we should always do. One more. 2 plus I over 3i. So here I have just the imaginary part on the bottom. So, but it kind of works the same way. And again, think of it, this is like if I had 0 plus 3i, what would be the conjugate? 0 minus 3i. So I'm multiplying top and bottom by a negative 3i. Top and bottom. So on top, it's more like a distributing. So it's negative 6i minus 3i squared. And then on the bottom, I'm going to have a negative 9i squared. So on top, minus 6i plus 3. On the bottom, I'll have, that'll become a plus 9, which in this case, well, my top, the order's wrong, but it looks like I can also factor out a 3 and maybe cancel. So I'm going to factor out a 3. So then this is going to be 1 minus 2i over 9. So the 9 and 3 reduce. 1 minus 2i over 3, which is the same as 1/3 minus 2/3 I.